All right, so this is where we left off. It said graph the following two equations, f of x equals 1/4 to the x and f of x equals 4 to the x, and draw the asymptotes. So this, we start with just doing our t-chart. So for 1/4 to the x, I'm going to plug in the same points we did the other day, -1, 0, and 1. So I get 1/4 to the -1, 1/4 to the 0, and 1/4 to the first. So what's 1/4 to the -1? 4. What's 1/4 to the 0? 1. What's 1/4 to the first? 1/4. So I'm going to plot those points. Okay, -1 and 4, 0 and 1, 1 and 1/4. So because there's no vertical shift yet, we haven't even gotten there, I know that there should be an asymptote at y equals 0, okay? Again, this is going to change. We're going to talk about it a little bit more in a second, but it's going to change as soon as I start to shift these up and down. There is no other asymptote, so there's no vertical asymptote here. That's going to switch when we start to deal with logs, okay? It becomes the inverse. Then I get 4 to the x. So I plot the same points. 4 to the -1 would be 1/4. 4 to the first, or 4 to the 0, sorry, would be 1, and 4 to the first will be 4. Plot those points, -1, 1/4, 0, 1, and 1/4. And it's the inverse of that first one, okay? So it also has a horizontal asymptote of y equals 0. Questions so far? So when in doubt, you can continue to plot points, but there's also going to be some shifts that are going to help us with this stuff. There's things, obviously, with our translations that we're used to that continue to apply to this stuff, which is this. So a vertical translation, a shift up or down, happens like always after the exponent. So if I had 3 to the x plus 2, it's taking that normal curve and shifting it up 2 places. If I have 3 to the x minus 2, it's taking that normal curve and shifting it down 2 places. This also causes a shift on the horizontal asymptote. So if I shift up 2 places, my horizontal asymptote shifts up 2 places. If I shift down 2 places, my horizontal asymptote shifts down 2 places. A horizontal, yep.
Are we allowed to have notes on this test or no?
On the quiz, I'll give you, yeah. I mean, I can't, at home, to give them a piece of paper and tell them they can work on it, how can I tell that, I'm not going to inspect that little piece of paper. How can I tell they don't have notes, right? So it will be the same for you guys, yeah. Horizontal translation happens left to right, and that's happening in my exponent. So if I have something added or subtracted in the exponent, it's causing a shift left to right on that curve. This does not impact my horizontal asymptote because I'm just going left to right. The reflection is a negative on the front, flips it upside down, so my normal curve, which looks like this, would flip over my axis and look like that. Okay, or if there's a negative in the exponent, it shifts it from going to the up to the right to flipping it over and decreasing, falling left to right. Okay, so if the if the negative is in the front, it flips it upside down. If the negative is in the exponent, it flips it left to right. So up, I would say upside down. Okay, so now it's going to keep my asymptote the same, right? But my range changes there. If it flips upside down, now it's negative infinity up to that point. A vertical stretch is caused by a number on the front. So the bigger the number on the front, okay, the bigger the stretch. If it's bigger than 1, okay? If it was a fraction, then it makes it flatter. And then horizontal shrink happens if it's in the exponent. So if I had something like 2x in my exponent, it's causing a horizontal shrink, which is this, it looks the same as a vertical stretch. So these I wouldn't stress too much about because you're going to be plugging in points. Okay, the vertical shift is a big deal because it affects your asymptote. But the rest of them, you're going to plug in your points. It obviously just makes it quicker if I already have a parent function to shift it, is what this is. So it says use the graph of f of x equals 4 to the x to obtain the graph of 4 to the x plus 3. We already did 4 to the x. When we plug in -1, we get 1/4. When we plug in 0, we get 1. And when we plug in 1, we get 4. So this is my parent function. So if I take that and I say 4 to the x plus 3, what's happening?
You move it to the right.
Close.
Or left.
Close.
Oh,
Up 3. So each of these points go up 1, 2, 3. This point would go up 1, 2, 3. And that point that's at the 4 would go up 1, 2, 3 to the 7. So it says, what's the domain and range of each graph? What would be the domain of my original parent function? Good. Negative infinity, positive infinity, all real numbers. What's the range of that graph? 0 with a parenthesis to positive infinity. Now, what's the domain of my shifted graph? Same. Still negative infinity to positive infinity. What's the range, though?
It's like 3.
Good. 3 with a parenthesis to positive infinity. If it had asked for it, horizontal asymptote here is y equals 0. Horizontal asymptote here is y equals 3. So it shifted up to 3. Question so far? So quiz question is not going to ask you to do both. It's just going to ask you to do a shifted one. So you're going to plug in points. It's going to ask you for horizontal asymptote. It's going to ask you for the y-intercept, domain, and range. Okay, things that we've been practicing. So the y-intercept here is 0, 1. The y-intercept here is 0, 4, which you would get by plugging in your points. All right, same parent function, so 1/4, 1, 4. Now I've got 4 to the x minus 2. What's happening there? What happens when the number's in the exponent? Well, close?
Oh,
Right, okay, so it is a horizontal shift, but it's going right 2 places. So I take this point, I go right with it. I take this point, I go right with it. I take this point, I go right with it. So what do these graphs have in common? What do they have the same of? Of, obviously, the points, but domain, range, y-intercept, and horizontal asymptote. What's the same? The horizontal asymptote's the same, both y equals 0. What else?
The domain and range.
Domain and range are the same. Domain, negative infinity to positive infinity. Range, 0 to positive infinity. Does that make sense? The only thing really this time that's different will be the y-intercept. To get the y-intercept on this, I'd have to plug 0 in. And I'd get 1 over 16. So the y-intercept on the blue would be 0, 1/16. The y-intercept on the red, 0, 1. So that 1/16 is what I mean by keeping answers exact. Okay, on your test, I don't want you using a calculator to find, I won't give it to you actually, to find that exponent to be -2. I want you to actually plug it in and keep it exact. Yep.
For our quiz, do you think we'll have enough time to just plug in points?
Yeah, you have to. I'm going to give you a T-chart. You're going to have to fill it in. Yeah. There's only 2 graphs. You'll have time. But the rest of them, the log stuff doesn't take long. I don't know if you heard that from home, but Christian just said, do we have time to plot points on our quiz? And the answer is going to be yes, you're going to have to. All right, then we get to the one-to-one property. So we talked about this a little bit, like not within the notes on Tuesday, but I just said, and it wasn't on the, right?
What?
I'm not allowed to talk about it, but it wasn't on that.
Anything
So it says for a is greater than 1, it's greater than 0 and not equal to 1, a to the x equals a to the y if and only if x equals y. All this means is if I get the bases to be the same, I think I hear it. That's air. If the bases are the same, then I can set the exponents equal to each other. Okay, and remember, anything raised to the power of 0 is 1. So here's my one-to-one property. The goal here is, if we can, and it won't always happen, but in the future we'll have a different way to do this. But if we can, change the bases of these to be the same by making the larger one a power of the smaller one, right? So we said the other day that 9 can be written as 3 to the second. Once the bases are the same, I literally ignored them and I just grabbed the exponents. So x minus 2 would equal 2, and then I add the 2, and I get x equals 4. These are easy to check because I can plug that back in. Okay, 3 to the 4 minus 2 is 3 to the second, and that's 9, which tells me I'm right. Okay, B, how do I get these to have the same base? There's more than one way to do this, but what's one way?
We did it on
Hmm?
Friday. We did it on Friday. We turned it into a 2.
Yep, we made this 2 to the 4th, right? We made this 2 to the negative 1. And I get 2 to the negative x equals 2 to the 4th, exponents equal. And x equals negative 4. And then this last one, which requires no work, but there's no other way to know it other than your rules on exponents. X would be 0, okay? The only way for a base to become 1 is by raising it to the 0 power. Questions so far? I know we talked about those, but I didn't put them on the video the other day. Okay, now we get to something called the natural base. So E is a symbol that represents a number, kind of like pi, okay? It's an irrational number, which means it doesn't repeat and it doesn't end, okay? It is 2.71828182, and so on and so forth. We approximate it as 2.7 if it ever says to approximate it. And it's called the natural exponential function if it's raised to the power of x. So these questions wouldn't be on the quiz, but they will be on the test. Like you're going to see e's. Well, unless it was like e to the first, okay? And that we would approximate to 2.7. It's called the natural exponential function. If you look at your calculators, you have a little button that says E, and then it should be near your LN button, because we're about to get to that tomorrow. On a graphing utility, it's on the left-hand side, 3 from the bottom, all the way on the left. Okay, and if I hit it, I have to get second it. If I hit just e to the first, you'll see that 2.718281828. This is where it comes from, and I'll never test you on this. But if I take this expression, which is exponential, 1 plus 1 over n, okay, to the nth power, this is like an increasing rate. And I continually increase my exponent by 1, okay, I would get closer and closer and closer and closer and closer to this natural base, which is that's 2.718281827. So the higher the exponent, the closer I get to that, the smaller the change in between. Okay, but as the exponent gets larger, the closer I get to actual 1 plus 1 over n to the nth power. And so that is what they replace with e. We just call it e, okay? That's where it originates from. All right, so example 7 says use a calculator to evaluate the function of f of x equals e to the x at each value of e, round to the decimal places. So these are the ones you're going to need a calculator for. Pay attention to the directions in the homework, because if it says to round, you're using a calculator. So e to the x, given x is 4.2, would be e to the 4.2, which is 66.6863, and that rounds to 66.686. So it says again, round it to the 3 decimal places. B says 125 e to the 0.05 times 30. This is where it's important to get to know your calculators. So on the portion of your test that you'll be able to use your calculator with, you can use either scientific or graphing, okay? Which means I can take that exponent and do it all at once. 125 times e to the 0.05 times 30. I can type it in exactly like that. And I get 560.211. If you're using a scientific calculator, you got it?
No,
So do 120, you know where the E is?
I don't have any.
Yeah, it's over the LN, so it's right here. You see this?
It's a different calculator, but
It should be the same though. You don't have E over the LN? Yeah, right there.
Oh,
Yeah, you have to hit second. If you don't have a graphing utility, then most likely, and you're using a scientific, you're going to take and multiply out 0.05 times 30, and you're going to get 1.5. Then you're going to do e to the 1.5, so there's a little e to the x button. You're going to do e to the 1.5. And that's 4.4816. You're not going to round that. You're then going to multiply it times the 175 or 125, and you get your answer. So know your calculator and know how to use it because they're going to be different. If you're using the calculator on the iPad, you're going to have to use the way on the bottom. You're using your iPhone calculator the way on the bottom. Turn your calculator sideways so you get the scientific, but then you're going to use the thing on the bottom. If you're using a graphing utility or one that saves it as you type it, then you can just type the whole thing in like this in the beginning. Everybody good? Questions? Good from home? Good. Okay, now we're going to graph with ease. So it says use a graphing utility to construct a table of values for the function, then sketch the graph of the function. So I'm going to take and make a t-chart just like I normally would by working out these values. And then I'm going to show you where that value is. So I'm going to do 4e to the negative 1 plus 2, which is 4e to the first. 4e to the 0 plus 2, which is 4e to the second. And 4e to the 1 plus 2, which is 4e to the third. And then just type those in. 4e to the first is 10.9. Obviously, I'm not going to go further than that rounding because how the heck am I going to tell the difference between your graph 10.9 and 10.87? I'm not measuring that. 4e to the second is 29.56, so 29.6. And 4e to the third is 80.3. Yep.
what number do you round to?
For graphs, I would say nearest tenth is fine. You're not going to be able to get any more accurate than that. Okay, so now think about what's happening here. If I took this in terms of what I used to know about transformations. The 4 on the front does what to a graph? What happens when I multiply by 4 in the front? Vertical stretch. So this should be quick to grow, right? The E is really just like saying 2.7, right? To the x plus 2. What's the x plus 2 doing?
Exponential.
Yeah, but what's the shift on the graph?
Goes left.
It goes left too. So if I had a graph of x to the, or 3 to the x, right? Let's say I had given you that graph because it's as pretty close to 2.7 as you're going to get. You literally would say that graph is shifted to the left 2 places and it's growing quickly. That's the other way to compare these, okay? So, but if I just plot these points and plan ahead, because if I'm going to 80, I'm going to obviously adjust my increments. Let's say this becomes 20, 40, 60, 80, but I'm going to keep my x values the same. Now I'm going to plot negative 1 and 10.9, so like halfway. 0 and 29.6, so right around 30. And 1 and 80.3. So where is my horizontal asymptote? At 0, was there a vertical shift? No, right? So horizontal asymptote, y equals 0. Where's my y-intercept? Close? No, actually not close. That's on the standard one, right? 29.6. I plugged in 0 already, right? I have that. I can get that from my points. What's my domain?
All real numbers.
Good. All real numbers, negative infinity to positive infinity. What's my range? 0 to positive infinity. No vertical shift again, right? Now, if I had a graphing utility, I could go to my y equals and I could type in 4e to the x plus 2. Like that. I could hit graph. And there's the graph, right? Which is basically just my overall shape. Now, if I look at my table values, so table is above the graph, those values should match what I got, which is clear, but they do, right? 0 is 29.6, 1 is 80.3. If I go up, there's my -1, okay? -24 would be the whole number there. So you can use a graphing utility to check these answers, but make sure you know what these answers are because you might have to do it without the graphing utility and just scientific. Questions on that one?
So like it's already shifted to the left 2 times.
It's already shifted, yeah, so our y-intercept got shifted over, well, n times 4, but it got shifted over, yeah. All right, last thing in this section is interest. So this is some application on exponential functions, okay? Compound interest versus continuous compound interest after t years, so t stands for time. The balance A, which is the amount of money that's actually in the account, with a principal P, P is how much you put into the account, and an annual interest R, which is in decimal form. So usually they'll tell you something's earning 2.5%. That means I have to take that percent and convert it into decimal. How do I go from percent to decimal?
Multiplied by 100.
Or what's the shift? It is that, but what? Move my decimal 2 places left, right?
So there's a lot of percentages.
Like original
There's like a lot.
increase, yeah. All right, so for compounding n number of times a year, this means I give you something and I say it's compounding monthly or weekly or daily or annually or semi-annually. Those are a certain amount of times a year. We use this formula. A equals P times 1 plus R over N to the NT. Again, R in decimal format is my percent. So if I had said 2.5, R would be 0.025. N is the number of times a year. So if it was annually, 1. Semi-annually, twice. Weekly, how many weeks are in a year? 52. Monthly,
40.
how many months are in a year?
Oh, it's about
12. Quarterly,
4.
4. Okay. Daily,
360.
365. All the things you have to know. And I would plug those in, okay? If it says compounding continuously, this means by the second, it means even faster than the second. It means this is naturally happening over and over and over and over and over again. And for that we use, I call it PERT, but it's P times E to the RT. So most likely I would give you these on your, and this won't be on your quiz, but this would be on your test. Most likely I would give you these formulas because why even pretend like you're not going to write them somewhere. Okay. Thank you so much. All right, so again, the further apart, so if I said something's compounding annually and then I say continuously, it's always going to be more money earned continuously. If I said like daily, like 365, you're going to get pretty close because that's pretty close to continuously, but continuously will always be more. So if I gave you the same measurements, if I gave you the same rate, the same number of years, the largest should always be continuously because it's happening more and more and more. So like if I said at the end of today, you earn 10% daily, then that means that if you put $100 in, you earn 10% today. What's 10% of 100? 10. Now, tomorrow you earn 10% of the 110. You with me on this? So it increases how much you're earning. Now, tomorrow you earn $11 on top of it. Yeah.
So for compounding per year, you're only multiplying it by 100 again? Like does your principal, does your amount?
Whatever your principal is. So your principal goes here. Whatever you put into the account. So yeah, so if you did it simple math, you would do 100. Okay, then tomorrow would be 110 times 10. So it would be 11. Then you do 100 plus 11. So 121 times 10. But this formula does it for you. All right, so it looks something like this. Find the accumulated value of an investment of $15,000 for 2 years at an interest rate of 3.2%. If the money is A, compounded semi-annually, B, quarterly, C, monthly, and D, continuously. So let's, again, write our formulas. So P1 plus R over N to the NT, or PE to the RT. So I need to know P. What's P? 15,000 is P. That's how much money I initially put into the account. I need to know R. What's R?
3.2%.
So 3.2% in decimal format is what?
0.032.
0.032. Good. Move my decimal 2 places. I need to know T. 2 years. And then I need to know for semi-annually, how many times per year is that? 2. For quarterly, how many times per year is that? 4. For monthly? 12. For continuously, I don't need it. Okay? So A, P, which is 15,000, times 1 plus 0.032 over N, which is 2, to the NT, 2 times 2.
We can have our calculators.
You have to, yeah. I mean, unless I said, like, just set it up. But so this won't be on your quiz. This would be on your test. Okay. Now, I'm going to type that in the calculator. If you have, and again, this is like that opportunity to make sure you know the calculator. I would make sure you learn how to do this on a scientific and also on a graphing. Graphing, I literally can type that all in. 15,000, open the parentheses. This is where it gets tricky. 1 plus, open the parentheses again, 0.032 divided by 2. Close them twice. Give yourself the caret 2 times 2. So I'm going to show you a picture of what it looks like because this is what people screw up. You have to enter it with the parentheses around the fraction. If you do not, it doesn't know how to read it. So with the graphing utility, you got to give it the parentheses here. Okay, otherwise your order of operations messes that up. So this should give you $15,983, and this is money, so we round to the nearest hundredth, 29 cents. 15,983.29. So it will probably not tell you what to round to on these. It's money. You have to know to round to the nearest hundredth. Okay, now B, A equals 15,000 again. 1 plus 0.032 again. This time my N is 4. And then 4 times 2. If you have the newer graphing utility, if you hit arrow up and highlight your, here, let me show you on a video, because this is a life changer. If you have this one, if you hit arrow up on this till you get to your formula and you hit enter, it's going to duplicate it. And then all I have to do is go in here and change the numbers I need. 4, 4, and there's my new answer. $15,987.31. Okay, C, A equals 15,000, 1 plus 0.032 over, monthly is 12, 12 times 2. Alright, so now let's talk about what this looks like if I have to use the scientific calculator or you have to use the one on your phone, because it gets complicated, okay? If I'm going to use that type of calculator, then you cannot work in the same order we just did. Where's my? Okay, so if it's a scientific one that stores your numbers, it's the same. So like this one, same. You just type it in. Okay, I could do 15,000. Open the parentheses 1 plus. Open the parentheses again. 0.032 divided by 4. Close them again. Caret 12. Oh, parentheses 12 times 2. So if it's that kind, that one, it's the same. If it's this kind, which is the kind that's like your computer, your calculator on your phone, okay, then you have to do this in reverse order. You have to do this first, 0.032 divided by 12. I get 0.002666. Then I have to add it to 1 without rounding it. And I get 1.002666 and so on. 1.00266. And then I have to raise that to 2 times 12, so I have to do the math on that first. So I hit the y=x button, I hit 24, and I get 1.06600, so on. Then I multiply that times 15,000. And I get that 15,990.02. So the order, wait, did I do that wrong? Hang on. Did I add first? 0.032 divided by 12 plus 1. What did I do here? I think I didn't take my 2. I forgot my parentheses. Yep, okay. So you should get that 15,990.02. So again, my advice is make sure you know how to do this on a graphing utility if you have it, and also on a scientific calculator, because there's going to be times in which you can't have that graphing one and you need to make sure you get the same answer. Okay, so those are compounded monthly. That was monthly, the last one. Now the last thing, D, is continuously. A equals P, which is 15,000, E to the R, which is 0.032, T, which is 2. And again, I stress this is different on a graphing utility than it is on your, like on the scientific one that Lockdown gives you, or on a scientific one like your phone. So on a graphing utility, you could literally type that in. 15,000 e to the 0.032 times 2, all in the exponent, 15,991.39. On this guy, which is like the basic one, which would be like your phone, you have to do 0.032 times 2 first, which is 0.064. Then hit second, wait, where's your E? All the way at the top. Then hit second ln, which is where the E is. So I did this. Then I hit second ln button, which is where the E is. And I get 1.06609, so on and so forth. Then I have to multiply that times 15,000. So So I basically go in reverse order, okay? So be really, really careful. I get the same answer. Make sure you know how to do it on whichever calculator you use. So if you're relying upon a scientific one, then make sure you know how to do it on a scientific one, whether it's like this guy or it's this guy. They're different, so make sure you know how to do them on both. Or the graphing utility. Just make sure you know how to use whichever one you're going to use. Questions? I'll be okay. All right, so that's all, again, exponential functions. So if you're trying to plan ahead in your brain, quiz will be the graphing stuff, the stuff that you can simplify, like the change of base, where you get the one-to-one property. And then we're going to obviously do logs tomorrow. If you're thinking long-term, as in the test, which would probably be the week after that, then think about all those interest problems being part of it. And graphs with ease, okay? Those would all be part of those. Questions for me?